Hi everyone, in this lesson I'm going to teach you how to do vector addition. Let's start by answering the question, what is a vector? Well, vectors represent quantities that have both magnitude and direction. We represent vectors using arrows. The length of the arrow represents the magnitude of the vector quantity, and the direction that the arrow is pointed represents the direction. Some examples of vector quantities include forces, displacement, velocity, and acceleration. For example, if we're looking at a rocket, and we know that that rocket's engine applies a thrust force of 50 newtons, we can represent that force using a vector. Let's look at another example. Imagine we have a skateboarder that's launching off of a ramp with a velocity of 10 meters per second and at an angle of 45 degrees. We can represent the velocity as a vector. And now that we've got a basic understanding of what a vector is, let's take a look at vector addition. Vector addition is just the process of adding two or more vectors. And the sum of these vectors is called the resultant. So we use vector addition to find the magnitude and direction of the resultant. For instance, imagine I had these two vectors, which I've labeled A and B, and I want to add them together. How would you do this? Well, the first step is to align the vectors tip to tail. Now, what do I mean by tip to tail? Well, if we look at a vector, the end of the vector is called the tail, and the front of the vector is called the tip. So when I'm doing vector addition, I will align the tip of the first vector with the tail of the second vector. And now we can draw the resultant. The resultant is a vector that's drawn from the tail of the first vector to the tip of the second vector. Since the resultant is a vector itself, it has both magnitude and direction. Let's do an example. Imagine we have two vectors, each of length 5 units and both directed straight up, and I want you to add them together. Well, we know we can align the vectors tip to tail, and then we can draw the resultant. We can clearly see that the direction of the resultant is straight up, but what would be its magnitude? Well, all we need to do to find the magnitude is add 5 plus 5, and that gets us a magnitude of 10. Pretty easy, right? Well, what about if the vectors are not in the same direction? So here we have vector A, which is pointed to the right, and we have vector B, which is pointed to the left. And I want you to add them together. And don't worry, because absolutely nothing changes. We still align the vectors tip to tail, and then we draw the resultant from the tail of the first vector to the tip of the second vector. Let's do another example. Here we have a vector of length 10 that's directed to the right and a vector of length 5 that's directed to the left. And I want you to add them together. All we have to do is align the vectors tip to tail and then draw the resultant from the tail of the first vector to the tip of the second vector. Now we can clearly see that the direction of the resultant is to the right, but how do we find the magnitude? Well, all we need to do is 10 plus -5, and that gets us a magnitude of 5 units. And now you might be wondering, why did I use -5 to represent the vector that's pointed to the left? And this brings me to a very important point. When we're representing vectors with numbers, we need to give that number the correct sign. So if the vector is directed to the right, it would be represented with a positive number. If the vector is directed to the left, it would be represented by a negative number. The negative indicates that the vector is pointed to the left. Same goes for up and down. If the vector is pointed up, it would be represented by a positive number. If the vector is pointed down, it would be represented by a negative number. The negative sign tells us the vector is pointed down. Let's do one last example to practice this. Here we have two vectors. One is directed straight down and has a magnitude of 10 units, and the other is directed straight up and has a magnitude of 8 units. And I want you to add them together. We can start by aligning the vectors tip to tail, and then drawing the resultant from the tail of the first vector to the tip of the second vector. And now we can see the direction of the resultant is straight down. But what about the magnitude? In order to find the magnitude, we need to add -10 plus 8. We use -10 to represent the first vector because it's directed down. And we use +8 to represent the second vector because it's directed up. Then when we do the math, we can see that the magnitude of the resultant is 2 units. So when you're finding the magnitude of the resultant, be aware of the direction of the vectors. And now here's one last note about vector addition. Vector addition is cumulative. And now what this means is that if we have a vector A and B, and we add A plus B, we will get the exact same answer if instead we had added vector B plus A. Think about it this way. If you add 1 plus 4, you get 5. If you add 4 plus 1, you still get 5. And visually, we can see this. If I add A plus B, this is my resultant. But if I add B plus A, I still get the same resultant. It has the same magnitude and the same direction. So don't worry about the order that you add vectors because it's cumulative. You will get the same answer. And now the examples we just ran through were very simple vector additions. Let's look at the different methods you need to use when it gets a little bit more complex, starting with the triangle method of vector addition. Let's say you have these two vectors, and I want you to add them together. Well, all you need to do is align the vectors tip to tail, and then draw the resultant from the tail of the first vector to the tip of the second vector. But what I want you to notice is that in this case, when we drew the resultant, we formed a triangle. And the reason that's important is because it will help us answer the question of how do you find the magnitude and direction of this resultant. And notice the direction is described by the angle within that triangle. Now, when you're trying to figure out the magnitude and the direction of the resultant, the first question you want to ask yourself is, did we form a right-angled triangle? If the answer is no, that means you have a triangle that does not have a 90-degree angle. So in order to solve for the resultant, which is one of the sides of the triangle, you will need to use the law of sines or the law of cosines. But don't let these equations scare you, because most of the time in first year physics, you will be dealing with right-angled triangles when you're doing vector addition. That means the vectors that you're adding together will form a triangle with a 90-degree angle. These right-angled triangles will have an adjacent side, an opposite side, and a hypotenuse. And the resultant is the hypotenuse of the triangle. And since we're dealing with a right-angled triangle, we can use the trigonometric functions to solve for the resultant. That means we can use sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, or tan theta is equal to opposite over adjacent. We can also use Pythagorean's theorem, which says c squared is equal to a squared plus b squared. And remember, c is the hypotenuse of the triangle, and a and b are the other two sides. So you can use these equations to solve for the resultant when your vector addition forms a triangle. And now let's jump right into an example. Here we have these two vectors. One has a length of 5 units and it's directed to the right, and the other one has a length of 8 units and it's directed straight up. And I want you to add them together. Well, all you need to do is align the vectors tip to tail and then draw the resultant from the tail of the first vector to the tip of the second vector. And you can see we formed a right-angled triangle. Now the first thing we want to do is find the magnitude of the resultant. And we can do this using Pythagorean's theorem, This tells us that c squared is equal to a squared plus b squared. So all we need to do is plug in our values for a and b, which are the two sides of our triangle, and then do the math to solve for c, which is the hypotenuse of our triangle. And what we find is that the resultant has a magnitude of 9.4 units. And now we need to find the direction of the resultant, which means we need to solve for the angle. To solve for the angle, you can just use your tan trigonometric function, because we know tan theta is equal to opposite over adjacent. And we can rearrange this equation to isolate for the angle. Then all we need to do is plug in our values for the opposite and adjacent sides and solve for the angle. And what we find is that the angle is equal to 58 degrees. And what this means is that the direction of the resultant is 58 degrees above the x-axis. And so that's how you use the triangle method to solve for the magnitude and direction of the resultant. And now there's another way that you could have visualized this vector addition, and that's called the parallelogram method. So if I give you vectors A and B and I ask you to add them together, using the triangle method, you would align them tip to tail, and then you would draw the resultant to form the triangle. But if you were going to use the parallelogram method, you would align the two vectors tail to tail. Then you would draw two lines that are parallel to each vector, and the resultant is the diagonal of the parallelogram. Now honestly, I much prefer the triangle method, but whatever method you use, you will get the exact same answers for the magnitude and direction of the resultant. Alrighty, let's do one last challenge question to practice everything you learned about vector addition. For this question, we have these three vectors, and I want you to add them all together. And now remember, because vector addition is cumulative, it does not matter which order you add the vectors. But I will tell you it's a lot easier if you start by adding the two vectors that are along the x-axis, because that means we can start with some simple vector addition. All we have to do is align the vectors tip to tail and then draw the resultant. Now we can see the direction of the resultant is to the right, but what about its magnitude? Well, all we need to do is add 8 plus -4, and that gives our resultant a magnitude of 4 units. Now we're done the first part of this vector addition. The next step is to take the resultant we just calculated and add it to the third vector, and then we can form our final resultant. And now we've formed a triangle, so we can use the triangle method to solve for the magnitude and direction of our final resultant. Let's start by finding the magnitude. All we need to do is use Pythagorean's theorem, which says c squared is equal to a squared plus b squared, plug in our values for a and b, and then solve for c. And what we can see is that the resultant has a magnitude of 8.9 units. And now let's calculate the direction, which means we need to solve for the angle. To do that, we can use tan theta is equal to opposite over adjacent. All we need to do is rearrange for the angle and then plug in our values for the opposite side and the adjacent side. And then when we do the math, we can see that the angle is equal to 63 degrees. That means the resultant has a magnitude of 8.9 units and is directed 63 degrees above the x-axis. And now if you were able to answer this challenge question, then you have a pretty good understanding of vector addition. Thanks for listening, and I hope you have a great rest of your day.